Hello, and welcome to this ANSYS space claim tutorial on doing a faceted shrink wrap for 3D printing analysis or other uses like a customer view model. If you haven't already, go to File, Open, browse to the directory where you downloaded, and you may need to change the file filter from space claim to all files in order to see the step file that we're going to start with. Here we could see we have a assembly of a hand drill, could be a consumer product, industrial, or the like. And if we go ahead and take a look inside through a cross section, if I hover over this cylinder and scroll to this axis inside and type X or click on cross section mode, here we can see through the middle of the part. Now, there are some certain display settings you may want to change. The model may be faded. So on the display tab, you could always change whether it's faded or not, or whether the model is clipped. I think this is a good setup right here. And if we go ahead and zoom in, we can see that there is some clearance, some space between some parts. In other areas, we have interference, and there might even be some clearance in there as well. And this is something that's common in models that need to be 3D printed. There may be gaps and spaces. If we go back to 3D with D on the keyboard, we could also see that there's some spaces inside of here between the teeth as well. And as long as we don't care about having a functioning mechanism with the 3D print, we may just want to print this as one solid blob. So inside of the Facets tab, which is an add-on designed to prep models for 3D printing, there is a tool called Shrinkwrap. Now, one thing that makes Shrinkwrap a little more robust is to take all of the parts out of their components. Oftentimes, having instances can affect how the Shrinkwrap works. So one easy way to do that is to box select everything in the design. You can right-click cut or Control X, just like in Office, and that cuts it out of the components. And then you can paste Control V or right click paste, and that pastes them back in outside of all the components. So if there's any issues with instances, that immediately gets eliminated. Now, creating the shrink wrap is very easy. All you need to do is select everything in the model, turn on the shrink wrap tool, or vice versa. You could turn on shrink wrap and box select everything. All you need to do is click the check mark. What impacts the result of the shrink wrap are the settings on the side. So the default setting is 0.394 inches, which is the equivalent of 10 millimeters. And there's an option to keep original bodies, which is off, which means the solids will get deleted and there'll only be a faceted mesh after. And then there's an option called preserve features. So let's just see what the default looks like. And then I'm going to switch over to a model where I have multiples of the same one with different settings. Keep in mind that with the default settings, it's pretty quick. But when you make this gap size similar to a resolution, the smaller this is, the longer this process takes. Also, when you preserve features, it takes longer as well. So here we could see a very rough shrink wrap that really doesn't look much like the model. So here I'm going to switch over to this design. And keep in mind, the way I made a bunch of copies, if you move something while holding down the control key, it will make a copy in that direction. So what I did to make copies was I box selected this, chose an arrow, hold control on your keyboard, and now when you drag, it makes a copy. So that's how I made the copies in this next one I'm going to open up. So I'm going to switch over here. This is the same model. And you can see all the way on the right something that looks far closer to the original than what we have on the left. So let's kind of go through a natural progression of the different settings to try. So right here, this is what we just did. It's with the default settings. Let me go ahead and go back to facets and turn on shrink wrap. So here, default gap size or resolution and preserve features is off. If we move to the next one, all I did, I left the gap size the same, but I turned preserve features on. And here you could see it's still pretty rough based on that size, but there are certain things to notice are more preserved. Notice the shape of the handle is more preserved. There's a sharp edge here, while here it was kind of smoothed over. Same thing on this side. You could start to see an edge representing the original disc, while here you can't. So you could already see that by turning on preserve features, it looks closer to the original. But what's most impactful is not the preserving of features, as you can see between here and here, but rather the decreasing of the gap size. Here I cut the gap size in half and I turned the features off. So the only difference between the first one or the first one, and this third one is decreasing the gap size by about half. And you could already see that it looks far closer, even with features off. The handle looks pretty close. Same thing with down here. And we can see more of the circular disc in the center. So here we could see that decreasing the gap size had a bigger impact than features. But now let's take a look at something with a pretty good resolution, but turning features on. So both the keeping with the point two, but now turning features on. Here you could see it's getting much, much closer to the original. If I zoom in here, you can really see some of the sharp edge definition, both on the disc in the center and the handle up top, and even on this bracket right here underneath. And I'm going to escape out of the shrink wrap tool. That way it doesn't highlight the whole model when I mouse over it. So here we could really start to see some definition showing even on the teeth. But, you know, point two is a pretty coarse resolution. Keep in mind, let me just go back to the drill here. If I select a face on the front, and I control select the face on the back. Notice this, the total distance on this is just under 13 inches, so a little over a foot, just to give you a point of scale. I haven't changed the size on any of these. So here we have the difference between point two with the feature preservation off and on. And then finally, with the finest resolution I did for this example, 50 thou. That's often a minimum thickness for 3D printers, so you probably don't want it any smaller than this. So let's go ahead and zoom in. If we look at point 0.5 with features off from here to here, I mean, it's night and day. Here it's very blobby. You may not even recognize what it was. Here you really start to be able to tell that it was this hand drill. But notice that if I zoom in, there are not sharp edges around here. The teeth, you know, they're barely recognizable. It just kind of looks like a coarse face at the bottom. In some areas, it even went straight across that. So, you know, while this is a nice shrink wrap, it's not preserving the features. And that's why we have that option and why we call it preserve features, because you'll notice if I look at the next one, which has the same exact gap size and resolution, but the features are on, notice if I just look at it from here, you can really clearly see these teeth compared to over here. And so that's what the preserve features does. What it looks at is the angle between facets. And if the angle is greater than this value, then it preserves it. That's why it preserved the 90 degrees between the top face and the side face. Other areas on this model where there isn't that sharpen angle, for example, between here and here, there was an angle smaller than 40. So that's why it's still rounded off a little bit and not sharp. So playing around with the angle threshold here, whether that option is on or off, and this gap size are really what influences this. But the biggest influence is the gap size, with preserved features further tweaking it to be a realistic. But one thing I want to point out here, I'm going to double click here to select those facets, and I'm going to hit X on my keyboard to go into cross section mode. I'm going to click on this move grid button, and I'm going to go ahead and move this down, let's say right into here. Remember, when I was in the cross section before, there was all sorts of clearance and interference, but the shrink wrap tool automatically removes all of that based on that gap size that you specify. It bridges any gap smaller than that value. So here we could see a nice, clean, solid model, no internal voids, no issues with clearance or interference. The last thing I want to show, and we're not going to actually do the shrink wrap one at a time. I'll kind of show you at the end what the different ones look like. But here's a model that's quite a bit bigger. I want to show you a scaling trick that I use, which really helps with shrink wrap. First of all, I want to show you that if I select this face on the side here and control select this one here, we have this panel at the bottom, and it's telling me that's 44 inches. Now, we may want to shrink wrap it full size, and we could always cut it into pieces and add, you know, ribs and pins to snap them together. But sometimes we just want to print it in one shot at a smaller scale. So what I'm going to do is I'm going to start by selecting this face as a reference, and in the detail tab, I'm going to turn on this dimension tool. And I'm going to dimension from this face here, the boundary on one side, to this face here, the boundary on the other side. So I'm just setting up a dimension from the boundaries of the part. And again, I want to go ahead and take all of this here, Control X to cut, Control V to paste it back in. So this just takes it out of all of those components, gives it a nice flat structure. That way we don't have any issues with instances when we create the shrink wrap. And you definitely want to do that before putting the dimension on. So again, doesn't hurt to show that again. I select this planar face as a reference to put the dimension. I turn on the dimension tool in the detail tab, click the face on one side, and then click the face on the other side, and now put that dimension there. Now, initially, this dimension is not useful. I can not just click it, type in a value, and something's going to happen. It just doesn't know what to do. What I am able to do if I undo that is tell SpaceClaim what I want to do. For example, I want to scale. So scaling is done with the pull tool. I'm going to box select all of the geometry. I'm going to turn on this scale tool guide, and I'm going to use my world origin as a scale point. After setting up the action I want to take on the model, there's an asterisk next to this dimension. And if I click that, let's say our print bed is 10 inches. So I'm going to do an even 10. We may want to round it down to 9.5, something to give us a little space, but let's just use a nice rounded value of 10. What happens when I hit enter is I'm telling SpaceClaim to scale the model based on the scale point of the world origin until this dimension is 10, and it'll get it as close as it can through an iterative scaling process. Sometimes it might be like 9.9999, round, as close as it can. In this case, it was able to scale it right to 10. So what's really nice is I don't have to calculate any scale factors. I could just drive it with this dimension. So from here, it's just a matter of facets, turning on the shrink wrap tool, selecting the body, and hitting the check mark. So let's go ahead and take a look at what it found, or at what the different settings look like on this model. So I'm going to zoom in here, and we can see that this is the default 0.394. And this model, by the way, this is actually scaled to 6 inches. So the resolutions might be a little different, but notice that here I pretty much did the same settings as the other one. Default 394 with the features off, 394 with the features on. You can definitely see some more definition, especially on this this cover right here. You don't get any straight edges, but here you do. The next one over is half of that, 0.2 instead of 0.4 with the features on, looking a lot better. Here, keeping the features on, but decreasing by half. So 0.1, we could definitely see far more definition here. We're starting to see it, but still a little coarse. When we go over to this one, far more definition. If we look at it from this angle, here it's a solid blob. Here, we're actually starting to see those ribs. Here, cut it down. So that was the 0.1. Yeah, so here we want the last two we want to look at 0.75 with features off and then with features on. So here we could see that it's getting far closer to the actual data, but it's still kind of rounding off edges and lumping things together. The ribs here, very jagged. But with the very last setting, 0.75 for a gap size with the features on, we can really clearly see the definition. We can actually, instead of seeing really coarse blobs for these bolts, we can actually see the heads of those bolts, actually starting to be able to see the ribs with nice, clean, crisp edges. So depending on the size of the model, what you're trying to do with it, how you're trying to print it, you just want to play around and try out those different settings with gap size and preserve features. Two quick things I want to mention is that the default settings are often very useful. For example, this model I did not scale down. This is still the full 44 inches. I did a shrink wrap on this with the default setting of 0.394 gap size, and I believe I turned on preserve features. Notice here, it's actually pretty good considering the size and that it's the default. So on larger models, the default option is very useful. It's just on smaller ones where this nearly half an inch gap size is too big. Secondly, I want to mention that the shrink wrap tool works on STL files. Here I have an STL version of the original CAD. This one will exhibit the same issues. If I go into a cross section and move this up into the part, Let me turn off this fit curves preview here. This still has the same interference between all of the parts. Now, the shrink wrap tool does work on this, but there is one selection tip that you should be aware of. You need to select the entire mesh body and not the facets. So what do I mean by this? If I click on the body at the bottom of this list and I hold down Shift and I select the top one, this will work if I click the checkbox. Notice it says here 20 meshes. However, if I click in white space to clear my selection and I do a box select, notice that instead of 20 meshes, it has 241,000 individual facets. If I click the check mark here, it does not work. If you want to use the box select method, because maybe it's hard to select from the tree, the one thing you need to do before you click the check mark is click this up arrow here. This is our parent-child select arrow. The parents of the facets are those 20 mesh bodies. So if you want to use box select to do a shrink wrap on an STL, you need to click on the up arrow to go from the facets to the meshes, and then the checkbox will work. Thanks for watching, and have a great day.